Hi, welcome back to another video on radioisotopes and their common uses. So we're going to look at uses of radioisotopes. This is going to be a pretty short list compared to how many are actually used worldwide, but we're going to look at some common ones and do practice questions. The first use we're going to look at should be something a little bit familiar: dating. So this is the process of determining the age of matter from the relative proportions of the radioisotope in a sample. When I say relative proportions, I mean the proportion of the radioisotope to whatever it transmutates to. So in terms of dating, you're looking at a known nuclear chemical reaction where you know the radioisotope is decaying into whatever element. The most common form of this, which you've probably heard, especially if you took earth science, is carbon dating. So carbon-14 is the isotope that's used for carbon dating. It is used for living organisms, so fossils in plants, animal bones, so on and so forth. The half-life of carbon-14 is 5,730 years. Just to recap, half-life is the amount of time it takes for half of your sample to decay into whatever element it decays into. For carbon-14, the relative proportions you would be examining is between carbon-14, so your radioisotope, and carbon-12, which is the element it transmutates into. Carbon-14, I think, is the one you hear the most because this is what archaeologists are using, but it's not the only radioisotope that's used for dating. Another common radioisotope is uranium-238, so carbon-14 is used for living organisms, or what was once living organisms. Uranium-238 is used for non-living matter, or non-organic matter, so rocks. For uranium-238, it's going to decay into lead-206, and this is used again to date geological formations, so formations left behind icebergs, or the different layers in a piece of rock. You can use the relative ratio of uranium-238 to lead-206 in order to get a relative date of when that formation formed. Here's a practice question. So which radioisotope is best used to determine the actual age of the Earth? So there's a couple ways to approach this question. So like we just talked about, carbon-14 and uranium-238 are used for dating material. The planet Earth is mostly rock, so the best choice here is going to be answer D, uranium-238. Additionally, carbon-14 only has a half-life of 5,700 and something years. That's not very long in terms of the Earth's lifespan. If you recall from middle school or Earth science, the planet Earth is about 4.6 billion years old. Uranium-238 has a much longer half-life, which you can actually look up in your reference table. Another common purpose for radioisotopes is in medicine. Again, I'm going to give you a pretty short list here. There's many more that are used. But key things here, radioisotopes in medicine are used as chemical tracers or cancer treatment. Those are the two main purposes. I'm sure there's other purposes that I don't know about. But just so you know, a tracer is a substance that can be used to follow the pathway through a structure. So for example, there's radioisotopes that you can drink, and then medical equipment will follow the track of the radiation through your digestive system, and you can see if there's anything blocked, for example. The key thing about medical radioisotopes is they have to have short half-lives. Short half-lives mean that they're not going to last a long time. They decay quickly, meaning they leave the body quickly. They decay into a non-harmful, as in non-radioactive substance quickly, and this limits the radiation exposure. So a few radioisotopes that you need to know for medicine are 1. Iodine-131. Iodine-131 is used to diagnose and treat thyroid disorders. Cobalt-60 is commonly used for cancer treatment. It emits gamma radiation, which is used to treat cancer. And then technetium-99 is used for brain scans and is a type of tracer used for that. So this helps in the diagnosis process. Here's another practice question. So iodine-131 is used for diagnosing thyroid disorders because it's absorbed by the thyroid gland, and the best answer is A, has a very short half-life. You can look up the type of radiation it emits in table N. Again, having a long half-life is not beneficial for a medical use. You want short half-lives in order to limit the amount of radiation a person is exposed to. Another field that commonly uses radioisotopes is food processing. So particularly canning, I think, is when these are used, but cobalt-60 and cesium-131 are used in food production because they kill bacteria, which ultimately allows food to be stored for longer. Additionally, I don't know if these specific radioisotopes were used, but there are radioisotopes that are used in order to help seeds continue to sprout so that there's more yield from said seeds, and also they've been used as tracers to see how fertilizer is circulating through crop plants. So they're also used to try to up the amount of yield that farmers produce. Let's try another practice question. Which statement explains why nuclear waste materials pose a problem? The best answer is answer choice D. A and B, short half-lives. If radioisotopes had short half-lives, that would mean they would only be here for a brief period of time. They wouldn't be a problem then, if they didn't last for long periods of time. C, long half-lives, but remain radioactive for brief periods. That wouldn't be so bad if they were only radioactive for brief periods, but that's not true. Making answer choice D the best. There's many radioactive isotopes. They have long half-lives. Some of them will decay into another radioactive element before they decay into something stable, and they can last thousands and thousands of years. So one of the issues with nuclear power is that the nuclear waste needs to continually be monitored, cooled, and stored properly. Even long after a plant closes, it has to go somewhere and be protected because that radiation is harmful to living organisms. Alright, that's it for this video. Like I said, that was a pretty limited list of isotopes that are used. There's many more that have other purposes, such as in industry, radioisotopes are used to measure how thin like a piece of metal is, and there's tons of uses that you could look up and may even show up in whatever career path you choose. But if you have any questions, please let me know. Have a good day.